Previous video, we looked at how to calculate the empirical formula when we're given the masses of reactants and products. In this video, we're going to look at a slightly different type of problem. So how to calculate the empirical formula when you're given the percentage composition. So typically in a question, they will tell you that a compound is made of a certain percentage of this element, a certain percentage of that element, and a certain percentage of another element. You're simply asked to find out, well, what's the ratio of one is to the other here? Okay, so again, we're going to work through these using side-by-side examples. So I'm going to do one on the left of the page, you do one on the right of the page. So I'm going to begin by getting you guys to just pause the video and take down the formula in green there so that when you look back, you know what you were doing. So how to calculate empirical formula given percentage composition. Okay, so you should have written down the heading and maybe split the page in two down the middle, and on the left, this is the question. We'll pause the video and take this down now. Right, so let's highlight the important things in the question. It says, on analysis, a compound was found to contain, so there are three elements here: carbon, hydrogen, and oxygen. This is how a question like this will look. They'll give you 3 elements or 4 elements or even 2 elements, depends how many are in the compound. Ask you to find the empirical formula, but the key thing here is they're giving you percentages. So these are the percentages of each element in the compound. So we'll begin here by writing down which are the elements we have. So I'm going to go ahead and do that. Elements. And I'm just going to use the symbols. We've got carbon is to hydrogen is to oxygen. We want to know the ratio of these three so we can work out the empirical formula. So let's write down the next thing that we know is, sorry, not the words, this will do, just the sign percentage. So let's clarify underneath each one what percentage of the compound is made of that particular element. So we're told in the question carbon is 54.54%. Hydrogen is 9.1% and oxygen is 36.36%. Okay, pretty straightforward so far. The next question is, well, how to find out the molar ratio? So to figure this out, we're going to need the MR. So we'll need the MR of each one. We're essentially going to take the percentage and divide by the MR, and that will convert it to moles for us. So I'm going to go ahead and find the MR of each one. The MR of carbon is 12. Sorry. MR of carbon should be black there now. Yeah, MR of carbon is 12. Hydrogen is 1. Oxygen is 16. And we're going to go ahead and find out how many moles of each one we have there. We do this by taking the percentage, 54.54, and divide by the MR. So 54.54 divided by 12, 9.1 divided by 1, and 36.36 divided by 16. The next line, we'll get the equals of them. We should get 4.55 moles of carbon to 9.1 moles of hydrogen to 2.27 moles of the oxygen. All right, so we're looking good. We know the moles of each element. Next thing we need to know is the ratio. Same as in the previous examples that we did in the last video, we want to work out a ratio. We need to know that this needs to be the simplest whole number ratio. It has to be the simplest. And to work this out, what we want to do is divide all 3 of these numbers by the smallest one of these numbers. Now, this is currently the smallest number, 2.27. So we're going to divide by the smallest. Again, this is the same technique that we learned in the previous one. So we take the lowest common multiple and we divide everything by that. Sorry, lowest common denominator. And we take 4.55 divided by 2.27, and that's going to give me 2. I'm going to do 9.1 divided by 2.27, and that's going to give me 4. And I'm going to do 2.27 divided by itself, 2.27 gives me 1. That's my ratio. 2 is to 4 is to 1. So my formula then, empirical formula is that we have 2 parts carbon, so C2, we have 4 parts hydrogen, H4, and we have 1 part oxygen. I'll just go back up and make sure that those elements do match. Yeah, so the 2 here was with the carbon. So 2 carbons, 4 hydrogens, 1 oxygen. That's why that's the empirical formula. Pretty straightforward, simple maths, easy enough to do. What I'm going to get you guys to do is go ahead, take this down. And so especially what I have in blue here, because this is going to be an outline. Go ahead and do that. And what we're going to do is you're going to apply that to this example here. Okay, so it says a chemist analyzed antifreeze in a car. So we've got the substance antifreeze. It was found to be 38.7% carbon, 9.68% hydrogen, and the rest was oxygen. Okay, so here's an extra layer of problem that we'll deal with in a second. So the first thing we're going to do is write down the elements. Pause the video, write down the elements. Good idea to write down the question at the top of the right-hand column here on your page. So write down the question. Then you're going to write down the element, write down the percentage, and there's one unknown percentage there, the oxygen. How would you work out what that is? So pause the video and make sure you do that. Okay, so this is what you should have done so far. You've got 38.7% oxygen. You've got 9.68% hydrogen, and you've got to figure out, well, the rest is oxygen. You know that it's always out of 100% in total, so you have to go ahead and figure out what the remaining percentage is. Right, the answer you should have got is 51.62%. Well done, you got that right. Next line, we've got to convert these to moles. So we need the MR. Go ahead, find the MR of these three things, and then work out the moles. How many moles of each one? Go ahead and do that. Right, so the MR of carbon, you should have got 12, 1, and 16. There are your three MRs. And then to work out moles, you should have got, for carbon, you should have got 3.225 moles. You should have got 9.68 for the hydrogen. And then the oxygen, you should have got 3.226, so very similar to the first one. Okay, so the next line is ratio. And you want the simplest ratio. So simplest. So you know the rule to get the simplest ratio of these three things. Go ahead and do that now. Okay, so if you didn't do this already, this is what you should have done. Taken the smallest number, which is, well, both of these are equivalent. Now, they're not exactly the same, but they're close enough, okay? And you divide all three numbers by the smallest number. So you're going to get 3.225 divided by itself. 5, which will give you 1, is to 9.68 divided by 3.225, and it should get approximately 3. 9.68 divided by 3.225. Now you might not get exactly 1 or exactly 3. You get 3.001. That'll do us just grand. We'll just round that to 3. And then this here is 3.226 divided by 3.225. You can see that's obviously going to be 1, okay, as a whole number. So empirical formula, go ahead and write down what that is now. Empirical formula. Empirical formula. Go ahead, write down what the final answer is here. Okay, so you should only be playing if you've written down the final answer. You've got 1, and this is for carbon, so this is carbon. You've got 3 parts hydrogen, so H3, and you've got 1 part oxygen, O. So there's your empirical formula for this, CH3O. Now this might not be the exact molecular formula. They might have more atoms. They might have more than 1 carbon atom. But then you would have, if you had 2 carbon atoms, you would have 6 hydrogens and 2 oxygens. Just the ratio that this is able to tell us. All right, so what you're going to do is take what you've learned there and apply it to 24 and 25. So that's what you're going to be doing here. 24 and 25 should be pretty straightforward. The same kind of ideas. And that's it. We'll go through them in the next class. I'll see you then.